Hi, my name is Szymon, and today I would like to talk about how a programmer thinks about code, and especially how this knowledge can be applied and used by us programmers and people around tech in programming, and also when building APIs and designing them and building libraries and just writing the code and working on it. Okay, but let me start with a quote. It was a quote I came across when researching and reading the papers on the area. And I found it very interesting because the authors of the Look into Programmers Head paper wrote that designing programming languages only marginally involves empirical evidence, and instead experience and plausibility are used. And I found it very interesting because it's a strong statement, and given that programming languages are a very scientific and a strict thing, the fact that we use mainly experience and no empirical process for designing their shape, their usability is very interesting. And let me step back for a moment and let me introduce myself. I am Szymon, and I work on the Scala compiler team at VirtusLab, closely with the teams at LAMP, at PFL, and the Scala Center. And I've been contributing to the Scala compiler, the Scala documentation, and I'm also coordinating the Scala Toolkit project. Okay, and today I'll be talking about the cognition in general, so how the human brain works in terms of cognition, of solving problems. And I will also talking how it applies to the programmer's cognition, so how a programmer thinks about the code when he reads or writes it, and how this knowledge is useful, and how we can make knowledge of the use of this knowledge, how we can make use of this knowledge, and how we actually did that in the toolkit. Okay, and the perspective I would like you to bear in mind today is that our cognition is the foundation of the way we write and read code. So for a programmer, the shape of the programming language should be in par with the cognitive model of the brain. And at the most basic level, I'm sure that some people know that, but let's go from the basic level. In our model of cognition, so in our model that we use to understand stuff, we use our senses, and we use them to perceive the symbols in the code. We use them to read the code, and then we are able to load those symbols and characters into our working memory. And in this working memory, we store them as something called the chunks. There is the rule of 7 chunks we can store in the working memory. It's kind of an oversimplification, to be honest, but you can use that to understand it, that you have a small working memory when you operate on the information that you have there, and you utilize the long-term memory that contains all the knowledge you have on programming in the process. And what are the chunks? So the chunks are the piece of information in our working memory, are like the basic unit of the information that we can operate on, and we group the information we have, like when we think about stuff, into the chunks. And so let's start an experiment so you can understand the chunks better. Okay, so try remembering this digit sequence, and the more digits you can remember, the better. Okay, let me give you like 10 seconds. Okay, how many do you remember? Probably not that much. That was a hard task. But let me reframe the experiment and try remembering these dates. Okay, how many do you remember now? I think that there's a high chance that you remember at least one date. And the thing is that those were the same digits. You're just able to group them and chunk them into a single chunk, and your brain is capable of thinking about dates. You have a way to chunk the dates and to group them and think about them, but you don't really have a way to think about the long sequences of digits because it's not what we use in real life. So the conclusion is that chunks allow us to group the information and think of it as a whole, and then we are able to operate on it and think about it and use them further on in our reasoning. And in programming, coming back to the core of the talk, so what are the chunks in programming? Let's look at this snippet. It's a tough snippet. I think that some people know what it does, but it's like the older syntax of operating on sequences in Scala. And if somebody was not familiar with the constructs and with the names, then he wouldn't be able to store them in his working memory and think about them efficiently. Because when you don't know the meaning of the symbols, you would need to store all the digits, all the symbols or the method calls and operators, and that's something that's just not possible. Even if you wanted to, for example, Google them and like find out what this one operator is, you just still like would need to look at this code constantly and help yourself with sometimes a piece of paper or something like that. Just because it's a very long snippet and you can't chunk it any further than you can see if you don't know the syntax. But on the contrary, when you have a clearer code that uses a lot of words that we are familiar with. So for example, most people are able to understand, even if they don't know Scala, that these are lists and they're added together. Maybe they don't know what fold left is, but even if they don't know what the fold left is, they just have one piece of information they have to like learn more about, and they can just Google it up and more swiftly go through the code and understand it. So this code would fit into our working memory, and therefore we are able to operate it on it efficiently. And the whole process of understanding the code is thought as in, we use two approaches to do that. We use the bottom-up approach and the top-down approach. And the bottom-up approach is the one we use it's the harder one. It's the one we use when we are debugging the code, when you don't know what's going on, and also when there's like a harder piece of code that we can get our head around simply. And it's basically merging, seeing the single symbol, seeing the characters, and merging them together into a like meaningful semantic meaning. So an example. For example, if you had a snippet like this and we were trying to apply a bottom-up approach to it, we would take the symbols from it, the fruits, map, etc., and then we would understand these symbols, and the symbols on themselves could be problematic to fit our working memory, but we have a context that's enough to make us transform the chunks into a meaning, and the meaning of this code we are able to store in our working memory. So that's what we do, and then we are able to integrate the whole meaning of the snippet and store it in our working memory. And the moment we store the meaning of the whole line in our working memory, that's when we can go further and read more code and understand it more. On the other side, there is the top-down approach. And the top-down approach is basically when we see the code and we've seen something similar before. On the naming of the variables, of the methods is simple and clear, and then we are able to deduce the semantics, what the code does, without going into details, without even reading all of that. And that's the way we approach the use. This way we use more often. It's like the faster one is the one we should seek when we just traverse the code and try to understand it. And for example, if we had a snippet like this, we would understand that the person JSON is like a JSON we fetch from somewhere. We should probably know from the context where it's fetched from. Then we process this JSON so we can deduce that it's like parsing it. And then we do stuff. We don't know what doing stuff is, but we can just go in there. That will be the bottom-up approach. But we can, again, apply the top-down approach and send the mail, for example. So we understand that in the top-down approach. So putting all of this together, the cognitive process, we have the sites. So we read the symbols into our working memory. We have the cognitive process that helps us integrate the chunks and read the code. And for that, we utilized our long-term memory that gives us the context and everything we know about the programming. And another interesting thing is that when I was like reading these papers, they actually made the research from a more like neuroscientific perspective. And what they did is they put the programmers or sometimes the beginners on different level of advance of knowledge. And what they did is they showed them the code, and they tried to make images of their brain while they were comprehending this code. And they had the way to determine which parts of the brain, which areas of the brain are being used and when. And that's what they did. And what they found is that, for example, the most used areas of the brain were the one corresponding with the working memory and the one that mostly corresponds to the use of the semantic memory retrieval. And another interesting thing you can see there is that the semantic memory retrieval is triggered earlier than the working memory. So that would correspond to the model that I showed earlier, that the first thing you do is you understand the symbols, you give them the meaning, and then you're able to work on them in your working memory. And that's exactly what in this paper as well they proposed. So it's like, yeah, yes, as I said, it's like more neuroscientific perspective, but I think it's very interesting that that's done in the area of the research on that. So to the practical side, what should you do based on all of that? You should take care of your colleague's brain by your program. So you should not fill their working memory. So you should use well-named variables. You should try to not make too big methods with too much dependencies between symbols, and therefore allow for all the symbols to fit in the working memory. You should allow a top-down, swift top-down comprehension when possible. And when it's not possible, when you have a harder piece of code, you should support the bottom-up comprehension that will also be fast. So name everything correctly and don't go too hard on the details, and then group them into the separate methods. And I have a short story because I was showing this presentation to a guy from a university in my hometown. He's a cognitive scientist, and he's seen this presentation and he proposed, because all I was talking about was about reading code. So how we can apply it to writing the code. And the interesting thing he proposed was that, and that he actually done before when talking about it, that the writing the code could actually be thought about as a reverse process of the chunking. So you start with a single chunk, a goal, and then you destructure this chunk and go into like a lower level chunks. And at the end, you end up with the structure of chunks in a lower level of abstraction that is then reducible to the first chunk we had. So for example, we have the goal. So for example, we want to send an HTTP request. We know what we want to do, and we start writing the code corresponding to each step we need to do in order to achieve that goal. So in the case of the sending HTTP request, we know we have to, for example, acquire a request object. And when we start doing that, we go and acquire an instance. We set the header, set the body, and we just go lower on the abstraction level from the cognitive perspective. And in general, I think it's also a nice way to think about the abstraction level in general, because some of the definitions of the abstraction level in libraries and APIs are often based on the more like scientific computer side of stuff, but abstraction level is actually something that we use as humans. So I think that's a better way of thinking, in some cases at least, about abstraction would be to think about it from a cognitive science perspective. So in this case, it would be the nesting level of the construction of semantic chunks. It sounds tough, but it's just, you have a basic chunk, that's the goal, and then you can go lower and lower, and it's not that strict, to be honest. It's hard to define abstraction level strictly, but I think it's a nice way to approach it. And the whole abstraction stuff will be useful later in this presentation. But the rule of thumb is that you can derive from that is that for a given abstraction, when you have a symbol, it's a good idea to not have more than 4 to 5 lower level chunks. So when you, for example, have a method in your library, probably all of us had a situation when they just went into like the definition of a library method and they found like a very long code. So that's the moment when you, on the lower abstraction level, you have just too much chunks. You are not able to comprehend it swiftly, and it would be better if it was following this rule. Okay, but the Scala Toolkit, so the thing where we applied this all. And the Scala Toolkit, that's the toolkitty, this cat. This is a mascot of Scala Toolkit. And the Scala Toolkit is the set of the battle-tested libraries from Scala community. And it's a collection of them that you can use. It works with Scala 3 and 2.13, and it works on JVM, on Scala.js, Scala Native, so all the platforms. And it's also integrated with Scala CLI. You can just use the using directive, the using toolkit directive, and the SBT, because there's a new feature in SBT that you can set up a new project, and you have a starter project, and the first default one is the Scala Toolkit one. And it's the whole artifact of the toolkit is published as the Scala lang toolkit. So for example, if you were to write the code using the toolkit, that's the old syntax of Scala CLI. You don't need to use the quotation marks anymore, but you can just write using toolkit. And for example, you have the STTP and UPCall library available, and you can just use them. For example, to send a JSON over an HTTP. And the Scala Toolkit in general is, we think that we want it to be well suited for microservices and in general, like bootstrapping your project without thinking what libraries should you use. So in general, also like greenfield projects and prototypes are also a good area to apply the toolkit. And also learning and teaching Scala. So when you have some students and you want to show the practical stuff being done in Scala, the Scala Toolkit should be we want it to be the go-to tool. And right now, the Scala Toolkit has the UPiCal library in it for JSON support. It has the STTP for HTTP support and OSLib and MUnit for testing. And there are definitely more to come very soon. And there's also the type level toolkit that was released, and that uses the same standard and has similar guarantees that the toolkit, but it has inside of it the basic libraries from the type level community. So you can just write using toolkit type level latest, and then you have the project set up with the CATS library and the type level stuff in Scala CLI. What's more, in the toolkit offers like Q&A like tutorials, the ones that you could, for example, see on Stack Overflow when you see the answers to the question, but like more standardized ones. And that's the set of like most basic tasks one would want to do in Scala when writing scripts or simple applications. And they are on the Scala Lang page, and they are live now, so anyone can visit and see them. And we wrote them with the VirtusLab and Scala Center wrote them. And another thing is that we take very seriously the compatibility. So for the toolkit, we apply every library in the toolkit has to follow the Semver, and the toolkit has to follow the Semver in a very strict manner. So it's applied to the whole dependency tree. It's a whole thing that we have a separate CI tool built for, and we want to apply it to other toolkits, for example, the type level toolkit. But we want to be sure that there won't be a problem of, for example, bumping the libraries and anything like that. So that's another advantage of toolkit. You just have a set of libraries that work well together, and when you bump the versions, they will also work correctly together, and they will also work on the LTS. So that's another thing that will make it easier to not run into any problems with bumping the versions. And going back to the cognitive stuff, the Scala Toolkit prioritizes the low cognitive cost. That's why we were discussing all the cognitive stuff, because we had to provide a way to define simplicity. We want to have the simple libraries, the one that are, the simple is a bad word, I don't really like it, but the ones that prioritize a low cognitive cost. And we have to prepare all this knowledge base to think about the ease of use of the libraries. So one of the specific tools we used are the cognitive dimensions. And that's not the first time they were used for rating libraries and programming languages. They were used before by Microsoft, but we kind of made our own version of them. And the cognitive dimensions are a framework that can be used to assess a cognitive cost of a given code. So you can get a library, look at the API, and look at how it's used in like specific code snippets, how people make use of it, and then in a set of criteria rate this library in terms of usability. But at the first step, you have to think about the target user, because there's no thing as a universally good library in terms of usability. Everyone has a different goal, and that's something you should always think about, that the code quality is subjective. And target we set for the Scala Toolkit are the scripts, the prototypes, and also the simple services being bootstrapped. But in general, we don't want to require knowledge of the more intricate stuff about the Scala language, and also any like the more advanced ideas around the functional programming, category fit theory and stuff. And the second step in using the cognitive dimensions is to define a test scenario. Because it's hard to think about the library in general. What's really interesting to us is like what would people really do with this library. So we have to prepare a class of problems, for example, HTTP. Then we can define a specific scenario, for example, making an HTTP request with something. And then we can look at the snippet, see how people would use this library, and determine if it offers a low cognitive cost for the user, the whole process of writing this snippet. And the first of the cognitive dimensions we used is, for example, the abstraction level. And the abstraction level answers the question, what abstraction level would feel natural for the user? So every user of a library, when wanting to solve a task, thinks on a specific level on abstraction. He doesn't want to go too deeply into, I don't know, the TCP stack. He just wants to send an HTTP request. Sometimes the user may want to think more about how the HTTP requests are made in bigger applications, about some queues and stuff. But in general, for Toolkit, we want to just approach the person that would script and write a simple application, sending an HTTP request and nothing more. So, for example, for a file reader, if you wanted to, for example, read a file and count some words in it, and here, I hope you can see this snippet, but I can broadly describe it that it just offers a trait with a file reader that has a higher kinded type taken as a type parameter, and when you would read file using it, you would return this higher kinded type of T of string. And for Toolkit, that would be an excessive abstraction over the execution model, because we don't want people thinking about the abstraction over the execution, as they just want to read a file, and it will be enough to return a string. And because excessive abstraction introduces a cost, from a lot of perspective, to be honest. From a long-term memory, we even require understanding what how the abstraction works. Not everybody knows how abstraction over the execution model works, and that's one thing we require. We also require from the working memory of the user to remember that he uses this execution model, especially when he combines a couple of them, some like directly and some like in some I/O. And from the top-down and bottom-up comprehension perspective, when you have an abstraction over the execution, you just have more symbols in your code. And that's another thing that you have to take into account, that it will slow down by a constant the cognition process in both top-down and bottom-up comprehension. And so, in general, the clever abstraction is cool, but we really want to concentrate on the purpose and consequences, and these consequences are often a cost in the libraries. And another example is the role expressiveness of the cognitive dimension. And we looked at the snippets and wanted to answer the question, would the person that's unfamiliar with the code and the library understand what the code does? So for example, in these snippets, if we look at the first one, it's a very short one. One could say it's like a smart, clever syntax, but on the other hand, it's like nobody would understand it if they didn't know the specific symbolic syntax. And we don't want to do that in Toolkit. Instead, we want to have explicit symbols and naming that is based in the pre-existing knowledge of the user. So no exclamation mark, but post. So the user could read it as a sentence. Okay, and I don't want to get into all of them, because we created quite a lot of them. But in general, we also use the visibility. So visibility denoted how easy it is to find some. For example, if you want to find another method that's similar to the one you have, how easy it is to find it. Or also, when you go into the definition of the method, would you find another stuff that you expect to find next to it and traverse the source code in general well. Also the consistency, so are the approaches and the patterns in the library and even the naming consistent, the domain correspondence. So are the symbols and in general the way of thinking in the library, does it correspond to the domain of the problem that it solves, and also the conceptual similarity to the ecosystem. So for example, if you had I don't know, an example could be that when the Scala standard way of handling so one situation would be to return a none, and the library throws an exception instead. That would be not corresponding to the ecosystem conceptually. And we also used a handful of other analysis methods. The language level, for example, so we don't want to use too hard features in the libraries and don't want to have them. There are also the structural measures, so the automated ones. So you can just run a program on an API, and then you can get some rating of this library in terms of consistency of naming, the structure, the size of the definitions and the classes and types. And we also applied many others, like is it well tested, are the maintainers responsive and available, and yeah, actually a handful of others. And the result of applicating of all of this was that we selected libraries for Toolkit. We have this framework to select more of them, and even have like the adding more is like in works. And we also cooperated with authors of the libraries to make them more usable in the perspective of Toolkit, of course. And so, for example, there was a proposal and PR merged made by Adrian from Scala Center that changed the API of STTP, because STTP previously offered an API with HKT, no hierarchical types by default, and now there is STTP4 released for partially because of that, and it's included in the toolkit, and it has simpler API according to our rule set of measures. And here you can see part of the spreadsheet that we used to read the libraries and choose them. And OK, so I would also like to ask you to take part in the toolkit process. And to do that, you can create issues with proposals in the Scala Toolkit GitHub repository. Some people were doing that already. You can also take part in the discussion on Discord, and that's both for the Scala Toolkit, so the one I was showing you, and the type level toolkit, as they have the Discord as well. And you can also create posts and discuss on the contributors thread, but it's not there yet. It will be released very soon. And it will be there very soon. And you can also come to the Scala Space booth in like a few minutes after the presentation, and I will be there, and I would really like to hear every comment you have. I can even show you all the spreadsheets that we used and stuff, so if you have any questions, comments, or suggestions, I would be very happy to hear them, because Toolkit is meant to make everyone's life easier, and it's hard to do it in one person and in a set of people. We have to get some feedback. OK, and the future. The future is that the Scala Toolkit will get early release in a couple of days, and by early release I mean the 0.2 release. It's still not a stable release, but for a reason. We could release a stable one, but then we wouldn't be able to apply breaking suggestions from the users. So what we want to do is release the early version, and according to the server, it will allow us to make breaking changes in future versions, and now gather the feedback from you and all the people. And if we feel like it's complete and we can log the feature set and not make backward, not incompatible changes, then we'll release the 1.0. But we will make the best effort to not make breaking changes in the toolkit even now. The collection of libraries is growing. We will be adding more libraries, and especially the one for the HTTP server is on the way, a database client. Those two are very important for us, and also a very big set of others that we have chosen. And we also want to explore other ways to apply the cognitive measures to other things in the process of developing the Scala ecosystem and the Scala itself. OK, and I really recommend you, because when I was preparing this presentation, I read quite some papers, and they were really good. So if you want to look into them, there will be a QR code at the end. That's the QR code. So you can scan it and look at the papers. But in general, thank you for your attention, and I would like to hear some questions if you have them.